Alright, so if we do some operations with decimals, let's start with some examples here. So let's say 430 plus 9,200. What's the sum there? Right? We could line this up doesn't really matter which one is up top because addition is associative and commutative. I guess because it's commutative doesn't matter which one's on top. But it's associative, which means I can add these hundreds to these hundreds and ignore the thousands and the tens, right? I don't have any ones for either number. I have 3 tens here, no tens here. I have 2 hundreds here and 4 hundreds here. 4 plus 2 is 6, so I have 6 hundreds total. And I have 9 thousands here. I don't have any thousand here. That's a 9. Now you probably could have worked through this faster than I did talking about it, but the point I want you to see is that we're adding hundreds to hundreds because they have the same unit, right? To add, subtract, or compare values, they must have the same units. That's the key with fractions, with whole numbers, with decimals, with word problems, is recognizing we've got to have the same units. So hundreds with hundreds, we can add that. So let's try another example. I'll keep it on the same page here so we can compare these. Let's say I have 4.3 plus 92. All right, well, 4.3 means 4 ones and 3 tenths. 92, I can write that here, 4 ones and 3 tenths. 4 and 3 tenths, the official name for that number. 92 means I have 9 tens and 2 ones. So 2 ones plus 4 ones, that gives me 6 ones. 9 tens, I don't have any tens over here, so that's just 9 tens. 3 tenths, I don't have any tenths over here, so that's just 3 tenths. So we could write it as 3 tenths if we're using formal expanded form here. Okay. So 90 plus 6, that's 96, and 3 tenths. There's our answer. Now this doesn't really look so obvious. It's kind of long. We have to pay attention. We want to line this up vertically the same way we lined these up, right? The whole point of this lining up addition method is to line up the places, the units. So 4 is counting ones, so I need to line up that 4 ones with the 2 ones. 2 ones, 9 tens. Right? I have ones lined up with ones. 4 plus 2 is 6 ones. 3 tenths plus no tenths, so there's 3 tenths. 9 tens with no tens. There's my 9 tens. Right? When we're adding, we line up the place values. How do we know the place values are lined up? The easiest way is to line up the decimal points. Right? 92 is the same as 92 and 0 tenths. Just like 4 is the same as 0 tens and 4 ones. So this 0 we often don't bother with. but if one of them has decimal points, it's often nice to put the other one with decimal points there. So we'll put that there. So our last example of addition. Let's pick a new color here. Let's say 0.043 and 0.92. So 0.043, that's tenths, hundredths, thousandths. That's really 43 thousandths. .92, that's point tenths, hundredths. That's really 92 tenths, hundredths, 92 hundredths. If I line up the decimal point, that 92 is not lining up with the 3. This is lining up, right? These don't have the same units, just like these didn't have the same units. If I want those units to line up, I need to, actually here the zeros are supposed to line up. I didn't write that very nicely. Here the zeros line up, right? The zeros are a way to show after the 0 comes a decimal point, after this 0 comes a decimal point, right? Hundreds, tens, ones. Thousands, hundreds, tens, ones. Tenths, hundredths, thousandths, tenths, hundredths, thousandths. If I want the units to be the same, I've got to multiply top and bottom by 10. 100 times 10, now I have thousandths. 92 times 10, I can think of this as 920 thousandths. 0.920, 920 thousandths. Now I can add them up. 3 plus 0 is 3, 4 plus 2 is 6, 0 plus 9 is 9. So I have 920 thousandths plus 43 thousandths, 963 thousandths. And without that decimal point, it would just be 963, right? That decimal point is telling me this 3 is in the thousandths place. So my sum here is 0.963. And this 0 here is optional. It's just a way, when we write 0.963 without the 0 here, that decimal point can kind of get lost. It's harder to see. We almost never will write 0 for 0.3 or 0 for 430. Right? We're not starting off a whole number with 0. So if we see a number starting with 0, our eyes are then going to look for where that decimal point is right after, or sometimes with extra zeros there. Okay, so that's adding decimals. Subtracting decimals works pretty much just the same way. So write these here. 430 minus 9,200. I'll write up there, 430, 9,200. 0 minus 0, 3 minus 0 is 3, 4 minus 2 is 2. 0 minus 9 is negative 9. This doesn't work, right? 30 forward, or I should say 430 forward, backing up 200, here's 430, backing up 200, that does get me to 230. But I'm not just backing up 200, I'm backing up another 9,000. That's 230, so if this is 0, here's 230. I'm going to continue backwards another 9,000, and I need to know how far to the left I've gone after that, right? In order to just do column subtraction, The number that's further from 0, the 9,200, has to go up top. So let's do the problem again the right way. 9,200 minus 430. 0 minus 0 is still 0 ones. 0 tens minus 3 tens I've got to borrow. 10 minus 3 is 7. 100 minus 400 I've got to borrow. 11 minus 4 is 7. 8 minus nothing is just 8. So if I've gone forward 430, and then I back all the way up 200 and an additional 9,000, so this whole blue line here is 9,200. It's certainly not to scale. I've gone past 0. How far past 0? 8,770. So I'm 8,770 below 0. Another way to illustrate that, if I'm starting at the negative 9,200, and then I move forward, right, 430 is positive, I move forward by 430. I'm moving back towards 0. I'm not as far negative. Instead of negative 9,000, I'm at negative 8,000, but not as far as 8,000, only 8,770. And maybe that's easier to see than this is. So that's whole numbers. Again, the hundreds are lining up with the hundreds, and then if I need to borrow, I do. Right? We're still lining up like units with like units. So if I switch over to 4.3 minus 92, well, which is bigger, 4 or 92, right? If I'm counting by ones, 9 tens dwarfs however much this is. Right? This is a much larger number. I'm going farther away from 0 this time. So when I do my subtraction, that farther away from 0 has to go up top. Ones place lining up with ones place, 2 lining up with the 4, and the tenths lining up there. Now, I can't just say 3 is 3. I have to borrow, just like over here I had to borrow. Right? 92 is 92 and no tenths. It also has no hundredths or thousandths or 10,000ths, but I don't care about hundredths or 10,000ths because I don't have any of those in my problem. So 0 tenths minus 3 tenths. Well, we can't take 3 dimes away from no dimes, so let's borrow from our dollars. Turn one of those dollars into 10 dimes. 10 minus 3, 7 dimes. $1 minus $4, can't do that. So borrow from our 10. Take 10 of those 10s, turn them into ones. 11 ones minus 4 ones, that's 7 ones. And now I have 8 $10 bills. Decimal point separating my tenths from my ones, right? With addition or subtraction, we're just keeping the place value here. Sometimes we'll need to borrow or carry. In this case, we don't. So 4.3 minus 92 is 87.7. So if we do one more example using decimals without whole numbers, 0.043 minus 0.92. This doesn't have any ones, this doesn't have any ones. Both of these numbers are less than 1. This says 9 tenths, this says 0 tenths, right? 90 cents and then 2 pennies. This only has 4 pennies, no dimes, 4 pennies, and then 3 tenths of a hundredth. So this is bigger than this one, so that 9.2 goes up top. Point, no tenths compared to 9 tenths, 4 hundredths compared to 2 hundredths, 3 thousandths compared to, well, I better put those thousandths in. Now you can subtract. So again, borrowing 10 minus 3, borrowing 11 minus 4, and 8 minus nothing is 8. That 8 is in the tenths place. I need my decimal point there. And if I'm worried about that dot kind of disappearing, I can put an extra 0 there. Right, that's really the only time you'd want a meaningless 0. I'm not going to say 92.0000 unless I'm really emphasizing how precise my measurement is. Right? When we're dealing with money, we never write 4.3 because we've agreed for money we always are comparing dollars and cents. So we've decided to always use 2 decimal points for that. But without the context of money, there's no reason to put an extra hundredths 0 here when that's not part of our measurement. Just like I'm not going to put extra thousands in front here. I don't specify how many millions I have. I know if there's nothing in that place, I don't have any millions. So this 0 is necessary to show that it's not 877, but that it's 8,770. This 0 is necessary so that I can borrow properly, rename properly, and then I'm showing where each place is with that. I've made one key mistake here that I'm just noticing. Hopefully you noticed it earlier. 4 minus 92 is not 87. Right? We talked about putting that 92 up top, but we have to recognize that's the negative value. It's negative here. Negative. Negative. So don't make that mistake. One way to avoid that is if we notice that it's going to be negative, write your negative sign first, then carry out the calculation. Okay, we get 87.7, and write that in. All right, so that's adding and subtracting decimals. We want the place value to be lined up properly. To do that, we line up the decimal points for each number.